these. It looks like you've done most of these.
Yeah. I feel like I've.
This is all your work, or is this some of this the teachers, or?
This is all mine.
Okay,
I just did tonight. Yeah.
all right. Let's talk about something.
Okay.
Whether I don't know if you are aware of it or not, but it's helpful to think of it. If
Okay.
you look at number one,
Uh-huh.
the middle two terms always combine, right?
Right.
The one on the left and the one on the right never do.
No.
So it's always the middle two terms. Same with number two.
Mm-hmm.
Same with number three. You're
Mm-hmm.
always combining the middle two terms.
Right.
So let's get to number four.
Okay.
Now, number four is different because it has a multiplier of 3 in front.
Mm-hmm. Yeah.
Well, I kind of have a rule in math, and that is always keep your numbers as small as they possibly can be.
Okay.
That leads to fewer mistakes.
Okay.
Now, notice that if we took this quadratic that's in the parentheses on number four,
Uh-huh.
and let's simplify it first,
Mm-hmm.
we get x squared minus x minus 12, right?
Right.
And then if I multiply that by 3, I get the same answer you got.
Mm-hmm.
The only difference is when you did it, you had these big numbers of 9 and 12,
Right.
which you then had to combine to give you minus 3x.
Okay.
Can you kind of see where it makes sense to simplify that before you multiply it by 3?
Yeah.
You're
Mm-hmm.
always going to be combining those two middle terms.
Okay.
And that's really important for factoring. In other words, if you're ever factoring a quadratic like that,
Mm-hmm.
always know that that middle term is the result of two things, the inside and the outside. That's what the O and the I of FOIL are.
Okay.
The outside and the inside give you your middle term. So if
Mm-hmm.
you're factoring and you're trying to figure out if you've factored it correctly, the only thing you need to check is your middle term, really.
Okay.
All right, let's look at number 5. A similar thing. What I would like to see you do on number 5 is solve this binomial times this binomial, simplify it, come up with your answer, and then put the negative sign in front of everything. It just makes it easier.
Okay.
Okay, so let's see. I can't even tell if you have the right answer because I can't force myself to do it that way.
Okay.
So leave
Yeah.
the negative sign out there,
Okay.
and then we end up with x squared. Let's see, minus 2x minus 7x. I'm going to combine those. That's one thing I don't mind doing in my head.
Mm-hmm.
Plus 14. So I get that first.
Right.
Now throw in the negative sign. Minus x squared plus 9x minus 14. And that's what you got. So
Yeah.
you did it correctly,
Mm-hmm.
but you did it a little more cumbersome. In other words, because you put the negative sign in there before you combine the two middle terms,
Mm-hmm.
it actually complicates the situation a little bit.
Okay.
Um, I guess it really doesn't now that I look at the way you did it.
Mm-hmm.
Maybe I'm just trying to come up with things to say. I don't know. Um,
Yeah.
but one of the things that I definitely can say is combine your two middle terms first before you do it. Same thing on 6. In other
Sure.
words, that plus 4x minus 3x is plus x.
Okay.
And then when you multiply it by 5, the biggest number you have is 5. Whereas
Okay.
the way you did it you have to multiply the 5 times the 4, which is 20, and the 5 times the minus 3, which is minus 15, and then you have to do the math of combining those two terms. But
Right.
you're just automatically, the way you're doing it, you're going to deal with bigger numbers than necessary.
Okay. Yeah.
And like I said, if you want to cut back on mistakes in math, always deal with the smallest numbers. If I'm going to do this, can you see my screen?
Yeah.
Okay. Well, I could do it by multiplying those two numbers together, but then I'm dealing with a big number. Why don't
56.
I reduce it first? 2
Mm-hmm.
times 7 is 14. If I reduce it first, the biggest number I'm dealing with is 14. I never have to deal with anything as big as 56.
Right.
So kind of use that as a guiding principle whenever you're doing math. Simplify first before you add additional stuff. And by adding, I mean before you incorporate the negative sign there, before you take into account the 5 here, simplify it first.
Okay. Definitely.
Let's look at this next one.
Okay.
Now this one you made a slight mistake.
Did I?
Well, notice that the second term is minus 12x, but the third term is also minus 12x.
Oh, is it minus 12x?
Yeah, it's x times minus 12.
Right.
Plus
so it should be minus 24x.
Right, exactly. And that's a good thing to know. In other words, what we're looking at here is a minus b squared. And it never ends up with an answer without a middle term. It's always a squared minus 2ab plus b squared. And if you know that, then you would never make this mistake. Because notice the answer you came up with is x squared plus 144. Where's the middle term?
Right. Yeah.
And it should be minus 24x. But that's helpful to know merely because it helps you identify when you've made a mistake.
Okay.
And that's really what math is mainly about, is figuring out how to be perfect. It's not easy to be perfect. And with math, it's not very helpful to be 96% perfect. It isn't. You have too many problems, especially in higher math, where you might have 12 steps. Well, you cannot make one mistake out of 100 calculations and get the right answer. You're just not going to do it. So if ever anything required perfection, it's math. More than baseball. You can play shortstop, and if you only make one error out of 100 plays, you're a great shortstop.
Exactly,
But
yeah.
if you're doing arithmetic and you make one mistake out of 100, you're doing a lousy job, because you know what's going to happen after a while?
It's going to start making the same mistake.
No, you're going to use a calculator.
Oh, yeah.
And what do you think happens after you use a calculator for 6 months?
You don't want to go back to doing the work.
Not that you don't want to, you don't know how to.
Yeah.
In other words, if I'm using a calculator to multiply 6 times 7 for 6 months, then I'm going to forget what 6 times 7 is.
Right.
And that's exactly what happens, is if you're not at least 99% proficient, you end up using a calculator all the time. And the moment you use a calculator for some period of time, you lose your ability, you forget it. We all do.
Right.
How to do it without a calculator. So that's a huge thing in society today, and it worries me a lot. Because I get too many students that don't even know how to multiply a number by 10.
Wow.
I mean, they pull their calculator out because they are completely dependent on the calculator.
Right. And that's like our society these days. You know, everyone relies on technology to
It
get
is.
them through life,
It
you know.
is. I watched a really interesting special on artificial intelligence the other day,
Oh,
and
wow.
I realized, some very good minds, Stephen Hawking, Elon Musk, Warren Buffett, Bill Gates, all say that there's a real danger in artificial intelligence. It might be
Hmm.
the end of mankind. And
Wow.
it's not a minor danger, it's a serious danger. That
That
they will
sounds
get
like,
smarter than us and take over, and then they don't have any need for humans.
wow.
But after watching this special, I realized what the greater danger was. The greater danger is, why would you go to medical school for 7 years if a machine can learn what you learn in 7 seconds?
Wow.
So what's going to happen to society? Nobody's going to
No,
do it manually.
right.
You
This is
just
going to
give
be,
a doctor a computer, and Watson, IBM's Watson, the one that won Jeopardy,
uh-huh.
it's a
Yeah.
better cancer doctor than doctors are
Wow.
already.
Oh,
And
jeez.
so how long is it going to be before humans don't go to medical school? And so to me, the danger really isn't that the machines will gain greater than human intelligence, it's that humans will become stupid. And
Gee.
the machines will be superior just because they're not losing intelligence like humans would be.
Right.
All right, let's look
Wow.
at number 8. I see a mistake in number 8.
Okay.
What you did here is correct except for one thing. What's
Hmm.
missing from that line?
The minus from that or parentheses.
Yeah, you got to carry forth the minus. You can't drop it. In other
Oh,
words,
I could have sworn I put it down there. Yeah, I guess I didn't put it down there.
no, and that's the
Yeah.
problem, is if you don't carry it every single line, it's real easy to miss it from your final answer.
Right.
Same thing with this 5 in question number 6.
Uh-huh.
Make sure you carry forth that number all the way through the problem. In other words, if you're going to do these the way I'm suggesting doing them, which is
Hmm.
do the linear parts, multiply them, simplify them, and then multiply by the coefficients,
Hmm.
make sure you don't forget the coefficient.
Okay.
And, oh, I see what you did here. Yeah, you almost put it in. In other words, you go from this row here, which
Uh-huh.
is x squared minus 12x plus 36,
Uh-huh.
and then you kind of put the negative sign in. You put it
Yeah.
into the 6x's,
Hmm.
put it into the 36, but noticed you left it out of the x squared.
Yeah, so that's where I messed up.
Otherwise, your answer is going to be correct. In other
Okay.
words, just
Yeah.
put a negative sign in front of that x squared and you're correct. But the
Right.
solution really lies in just bring that negative sign forward until you get ready to write the last line.
Hmm.
Then it's not confusing. In other words, if you just always bring it down, then you can change the sign of every term as the last step.
Okay.
Okay, number 9 looks fine.
Cool.
10. Now,
Did
notice,
I do that again?
no, you did it perfect.
Yeah.
But notice the answer. What is that called? Difference of perfect squares.
Uh-huh.
And that
Right.
always factors into an x minus and an x plus.
Okay.
So when you see the x minus the number and x plus the same number,
Hmm.
know that when you multiply those two together, you're going to get difference of perfect squares as an answer.
Hmm.
So you would not expect a middle term here, and if you get one, you've made a mistake.
Right.
So it's worth recognizing when you have difference of perfect squares in a quadratic, and it's also very worth recognizing when you have the factored version of difference of perfect squares.
Hmm.
because it actually makes it really easy to multiply these two together. I know
Okay.
that the middle terms are all going to disappear. They always do, 100% of the time. So the only thing
Mm-hmm.
I'm going to be left with is the x squared and the minus 25.
Cool. Okay.
11. Okay, that's good. Again, on 11, I would simplify the part that's in the parentheses before I multiply it by minus 2.
Okay.
Because notice
Sure.
when you multiply it by minus 2, now you got these big numbers minus 16 plus 10. Whereas if you'd have combined those to begin with, you'd have had 3x.
Mm-hmm.
Now multiplied by minus 2, minus 6x is the biggest number you see.
Right.
So that's the advantage of simplifying first before multiplying.
Cool. Okay.
Number 12. Again, we immediately recognize we're looking at the factored version of difference of perfect squares.
Mm-hmm.
So I could immediately say that's x squared minus 4,
Okay.
then multiply by minus 7.
Okay.
13, very straightforward, simple, can't add anything to that. 14,
Mm.
square it, but be very careful.
Okay.
Notice that the line you wrote there does not have the minus 4 there.
No.
That's asking to make a mistake.
Okay.
Now, somehow, when you got to this part, you picked it up and brought it down.
Uh-huh.
But it's really easy if you leave it out of the first row to leave it out of the
Mm.
whole thing.
Okay.
Because,
Yeah.
so just be careful of that. What I'm mainly trying to do is give you tips on how to cut back on errors.
Yeah, definitely. All right. Yeah, I appreciate that.
This is fine.
What?
15,
Okay.
16. Now 16, let's see how you did this.
Mm-hmm.
8x minus 2x squared minus 4 plus x, okay. And then the trick is to simplify that before you distribute the negative sign, but there's no real harm in the way you're doing it.
Mm-hmm.
It looks like you did it right, and then you simplify it. Your final answer here
Mm-hmm.
should have the x squared as the first.
Yeah. Yeah.
Whenever you're
Yeah.
writing a polynomial as an answer, always put the highest degree first, and the next highest degree next, and so forth and so on.
Okay.
Yeah, so the final answer would be 2x squared minus 7x plus 4.
Okay.
This one, before we go on, let me say something about 16.
Sure.
In other words, if we leave the negative sign outside for a moment,
Mm-hmm.
there's really nothing wrong with the way you did it. I just want to point out some stuff.
Okay.
Notice that this is unusual. In other words, in the second term here, the x is not first, it's second.
Right.
So how would
We
I
could
change
switch.
that? If I
Yeah, we
wanted
could
to
switch.
make that look more normal, notice that if I take that minus sign,
Uh-huh.
what is that equal to? That's equal to x minus 4.
Yeah, exactly.
A minus b is always equal to the negative of b minus a.
Mm-hmm.
Useful thing to know. In other words, you can immediately take this problem and eliminate any confusion by that negative sign.
Mm-hmm.
In other words, if I want to take that negative sign and distribute it to the 4 minus x, then the real problem I have is this.
Right.
Now, piece of cake, right?
Definitely.
Now, the
Yeah.
way you did it was very methodical and nothing wrong with it at all.
Okay.
The only reason I even mentioned it is because not everybody is aware that 4 minus x is the negative of x minus 4.
Right.
And once you turn it into x minus 4, it looks a lot more normal, and you've gotten rid of the negative sign. And so,
Mm.
again, less chance to make mistakes.
Okay.
That's really what math is all about. Okay.
Yeah, for sure.
Well, actually, I shouldn't say that because computers and calculators now kind of take the mistake out, and the most important thing is that you set it up properly.
Right.
Minor math error in number 18. What's 10 plus 21?
Um, it's minus 10 plus 21.
Excuse me.
Right.
Right? But it's still not 12. It's 11.
Oh, it's 11. Yeah, my bad.
That's all right.
Yeah.
All I'm doing is checking to see you don't have mistakes.
Yeah, no, no
Again, on
problem.
19, I love what you're doing here, but make sure you put that 9 in front of that first row. Just to
Okay.
ensure that you don't
Forget about it.
forget about it, yeah. And
Hmm.
again here, add the minus x to the other minus x to get minus 2x, and then multiply by 9.
Okay.
Um, I think you got a sign. No, no, you're fine on number
Like,
20.
okay.
Look at 21.
Yeah.
Now see here, you brought that 1/2 down immediately.
Yeah.
Yeah, you
I
didn't
just got
leave
it
it out of
faster.
that row.
Right.
2x
Just gotta do that
squared
first.
minus 7x minus 8x plus 28. Okay. Then I like combining. The only reason I like combining is because I want you to know that when you have a binomial linear term times another binomial linear term, the two middle terms always combine.
Right.
Better that you do it now than wait. Notice the problems that happen when you wait it.
Uh-huh.
Now you end
Decimals.
up with 3.5.
Yeah.
Well, you didn't need to end up with 3.5.
Mm.
Well, if you combine these two terms, I guess you have minus 15. Whoa, something's wrong. Um,
Yeah.
yeah, somehow you changed the sign on this 3.5x incorrectly.
Oh, did I?
It's not plus, it's minus.
No, it's minus. Yeah.
Even
Oh,
doing
that's why.
it the way you did it. And that's one of the hazards of doing it the way you did it. In other
Mm-hmm.
words, if you combine those two first, you have minus 15x, right?
Right.
Half of
Yeah.
that is minus 7.5x.
Okay.
Okay? By
Mm-hmm.
leaving those two terms separate gives you an extra opportunity to make a mistake. And you did. You changed the sign on one of them.
Yeah.
And it's not, doesn't have anything to do with you, Dylan. Don't take this
No.
personally. I'm just saying
Oh,
anybody
no,
in
no.
math, the fewer opportunities you give yourself to make a mistake, the better off you're going to be.
Yeah, definitely.
All right, 22. You don't show your work on 22. The only way to really do 22, I'm not sure how you came up with this answer, but the way to do 22 is you kind of have to multiply the first binomial by the second binomial, come up
Okay.
with an answer. Let's do it real quick.
Sure.
So x minus 2 times x minus 2 is x squared minus 4x plus 4. And then I'm going to multiply that by x minus 2.
Okay.
In other words, you really need to show that step.
Right.
And now notice that we're multiplying a trinomial by a binomial.
Mm-hmm.
FOIL doesn't work for that.
No.
But what works is ET, ET. Every term by every term. In other words, I take that, multiply it by that, take that, multiply it by that, take that,
Okay.
multiply it by that, take that, multiply it by that, take that,
Mm-hmm.
multiply it by that, take that, multiply it by that, and add all the terms together.
Okay.
And if I do that, I get x cubed minus 2x squared minus 4x squared plus 8x plus 4x minus 8.
Mm-hmm.
Now notice that when we have a trinomial by a binomial, those two terms combine and these two terms combine.
Yeah.
The term on the far left and the term on the far right, they don't have anything to go with. So
No.
you get x squared minus, or x cubed minus
Mm-hmm.
6x squared plus 12x minus 8. Is that what you got?
No.
And I'm not really surprised because you didn't really show your steps here.
Right.
And
I was just
unless
kind of
you do
confused.
that middle step, in other words, you have to multiply that by that before you can multiply it by the third term.
Okay.
Okay? And then you have to know how to multiply a trinomial by a binomial. Well, it's just
Okay.
like FOIL, but FOIL doesn't make any sense when you have a trinomial. It doesn't mean anything. I mean,
No.
what's the outside and the inside? It doesn't have any meaning. But
Right.
ET, that's why I actually prefer to teach people ET, which works when you have a situation where FOIL would work.
Mm-hmm.
In other words, all FOIL is every term by every term, right?
Right.
Basically what you're doing. That's what the F, O, I, and L do, is let you multiply every term by every term. But when you get to a
Mm-hmm.
trinomial by a binomial, it doesn't work. It's not helpful. But
Okay.
ET always works for everything.
Okay. Cool.
And finally on 23, same comments, nothing different. You multiply
Mm-hmm.
those, bah, something is different. You forgot to carry the 3 down.
Right.
And that gave you the wrong answer. In other words, your answer here is just 3x minus 5 squared.
Yeah, that is right.
And then you have to multiply that by 3. So the true answer should be 27x squared
Minus 90x.
x plus 75.
Okay.
All right?
Yeah. Okay.
All
Cool.
right. That's
Alright.
good. No, that's actually a good session. It
Yeah.
helps that I could give you some of the tips that I gave you because I
Yeah, definitely.
think it'll help you on these kind of problems.
I do too.
Yeah.
Yeah.
Okay,
Alright,
John.
cool.
Have a good rest of
Alright.
your week, and I'll talk to you next time.
That sounds good. Alright. Thank you, Mr. Cowan.